Hey guys, this is part 2 of lesson 5.9, which is what we were just doing, angles and polygons, okie dokie. And so the fourth question, or the fourth prompt, tells us to use the patterns from the table to explain how to determine the sum of the measures of the interior angles of a convex polygon with n, or a certain number of sides. That's what the n means, okay? So they give you a number of sides. This is how you determine what the sum of the measures of the interior angles are. You're going to subtract 2 from the number of sides to determine how many triangles are contained in the polygon, and whatever that number of triangles is, you're going to multiply that by 180 degrees. So essentially, you're taking 180, and this is the formula that you will use, and it's derived from that pattern, that chart that we just made, 180 times the number of sides minus 2. Because if we go back to this, that's essentially what we did here, okay? So we have a triangle which has 3 sides. We subtract 2, right? Because a triangle has 3 sides, like I said. We subtract 2, and then we get 1 triangle, okay? And that's how we get 180. Quadrilateral has 4 sides. Subtract 2 from that number of sides. That's the number of triangles that can be made in a quadrilateral. Multiply that by 180. That's how you get 360. Pentagon has 5 sides. Minus 3 times 180 is equal to 540. And I'll show you that here. So the formula is essentially asking you to do this. 5 minus 2, right, is going to give you 3. Multiply that 3 times 180, which is equal to 540. So that's what the formula tells you to do, to figure out the number of, or the measure of the interior angles of a polygon. Again, in the case of a hexagon, subtract 2, you're going to get 4. Multiply that by 180, and that's how you get 720. Okay, so that's how this formula works. And you're going to be practicing that on IXL. That's why the IXL unit is so extremely important, okay? Number 5, I'd like for you to do by yourself and to draw your own conclusion. That will be checked on Monday when I do check the notes. So it says, do the side lengths of a polygon affect the sum of the interior angle measures? Explain, okay? So based on what we talked about, I want you to come up with an explanation for that. Alrighty. Number 6, though, in a regular polygon, how can you determine the measure of one interior angle and one exterior angle? Let's talk about determining the sum of an exterior angle. In the case of a triangle, you see that I already filled in the information. I made a video prior to this, and then I got interrupted with a phone call. So I already put in the information here. I'm just going to explain it. Initially, I was doing it along with you, but no biggie. Hopefully it still makes sense. If it doesn't, post a comment in the description box or a question, or send me one on Jupyter. So we're trying to figure out, in a regular polygon, that means that all the angle measures are the same. So in this case, this is an equilateral triangle, and in an equilateral triangle where all the measures of the angles are the same, they're all 60 degrees. Just like in a square, which is a regular polygon, all angle measures are the same, all interior angle measures are the same. That's what a square is. So this is a regular polygon, so is this. And then this pentagon is also a regular polygon. All of its interior angles are going to be the same measure. Now, looking at this triangle, this equilateral triangle, we figured out that the exterior angles, or even if you look at the exterior angles, they are linear pairs, okay, to the interior that they sit right next to, or they share a side with. Like in this example, right? You have this exterior, the interior that it shares a side with, they make a linear pair. Linear pairs are supplementary. So if this is 60, then the exterior angle is 120. Same thing here, linear pair, okay? So again, if this is 60, that's 120, that's 60, that's 120. Supplementary means that they add up to 180, or basically they make a straight line. All right, so same thing here. We have a 90-degree angle here. Then, of course, its exterior angle is 90 degrees because they are supplementary, and 90 plus 90 is 180. Same instance here, same instance here, same instance here. Okay? So the sum of the measures of a pentagon, like we saw here, is 540. To determine the measure of one of those interior angles, how would you figure that out? Well, if there are 5 angles, and I need to split those 5 angles up into 5 equal measures, I'm going to divide 540 into 5, right? So I'm going to take 540 divided by 5, and that gives me 108, which means that each of these interior angles is 108 degrees. Okay, and so we have linear pairs all around here. Linear pairs, linear pair, linear pair. And so how do we figure out what the measure of those are? They're supplementary, so I need to subtract 108 from 180, which gives me 72. So that means each of these are 72 degrees. Okie dokie. Again, the exterior angle to a regular polygon is supplementary to its interior angle. Now, going back to the question of how can you determine the measure of one interior angle, let's make an octagon and let's check it out. All right, so an octagon is an 8-sided polygon. Kind of looks like a stop sign, and because it is a regular polygon, all 8 sides, 1, 2, 3, 4, 5, 6, 7, 8, they're all equal length and equal measure, okay? So all of these are, I'm going to just indicate with one arc, all of these are the same angle measure, and so there's 8 angles in total. Let me make sure I have the correct amount. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if I know that the sum of the interior angles of a polygon, well, how do I determine that? A polygon has, I'm going to use this formula here. A polygon has 8 sides. I subtract 2. That means, let me just bring that up a little bit for you. That means that 8 minus 2 is 6. Then I'm taking 180 and multiplying it by 6. Or I could have just looked at the chart on the previous page, and I get 1,080. That means the sum of the interior angles, if I add up all of these, is 1,080. Excuse me, not 180, 1,080. And taking that 1,080, I would need to divide it up into 8 equal parts. So I'm just going to take 1,080 divided by 8, and then I can determine the measure of one of those angles. And 1,080 divided by 8 gives me 135. Okay, so therefore I can conclude that each of these interior angles here are 135 degrees. And I'm just going to write that on one of them, right? I'm only writing the 135 on one of them, but because I use the same number of arc marks for each of the interior angles, it means that they're all the same measure. That's how I determine the measure of one interior angle. What if I wanted to figure out the exterior angle to this right here, or right to this one? So this is 135. To figure out the measure of its exterior angle, these two are supplementary. I would take 180 minus 135, which would give me 45 degrees. This takes a little bit of practice, but it's pretty straightforward, and hopefully if you do have any questions, you will reach out to me via Jupyter or in the comments section of the video. Again, your G2 IXL is due on Monday at 5.